Good morning, everyone. I'm excited to be here in Seattle to talk to you about the future of projection because there's a lot of stuff going on in the world of projection, and there's been a lot of talk over the last few years, especially with the advances in flat panel display technology about projection disappearing. And so we'll address that directly and talk about sort of what areas that projection is going to play in the future versus where we are now, and also some of the technologies that are ultimately going to affect the future of projection and some of the applications and opportunities that you have for projection in the future. I would like to mention that we are actually recording this session, and therefore you will be able to watch this again if you are so inclined. But more importantly, if you have people who didn't attend today that you think might benefit from this session, we are recording this session, and if you give us a few days, we'll put this online at ravepubs.com. And there's really a couple of advantages. Number one, I hope that you enjoy the education that you're going to get today. Number two, this session is also Infocom/Avixa now. As you know, they're called Avixa. CTS RU approved. So for sitting through this session, if you do have your Avixa CTS certificate, you'll get 1 hour of credit for this session. If you are not here, or if you have colleagues that are not here that want to get that credit, if they'll watch this session online and take a test afterwards, so they'll have to answer 8 questions. You won't have to answer them because you're here live, but we need some way to verify that they actually saw and watched the video online. If they answer those 8 questions correctly, then they can get an hour of CTS RU credit as well. So this can be a good continuing education opportunity for you as well. So you can follow us in pretty much anywhere and find a link to this session today. I want to thank Epson for inviting me to do this today. It's a beautiful location. It's exciting to be here in Seattle. It's a great town, and we've enjoyed the time we've been able to spend here. And of course, being here at this field is pretty awesome when you're sort of in awe of something like this. Even when there's no game, you know, you can't help but be kind of in awe of this location. So this is, of course, a session that is sponsored by, and you are here on behalf of Epson, but I'm not going to talk specifically about Epson as much as I'm going to talk about the products and the technology in general, but there'll be certain things that I'll talk about that are Epson related so that you'll have an opportunity to go around here and check them out while you're here. I do want to make sure that you have a chance to see those things. So as I mentioned, this session is CTS RU approved, so you will get credits for those of you who are here live, and you can get credits online by taking the test afterwards. This session today, the future projection, really comes down to 2 big things. One is resolution and the other is color. And I think one you've probably heard a lot about, and maybe you've experienced, maybe you've even had the opportunity to put in some of the new technology with a much higher resolution than what we've had before. But these 2 factors here are playing a big part in the future of our industry, both in projection and in flat panel technology. And I'll explain to you why, because this is the only time in my almost 30 years in this industry that we've had a collision of 2 giant technological advances happening at the exact same time. We've had a lot of, over the years, a lot of technological advances that many of you have lived through if you've been in the industry more than 10 or 15 years. But in my memory of like I said, almost 30 years I've been in this industry, I don't remember a single time we had 2 major technological advances happen at the exact same time. And I'm calling this the perfect storm of resolution and color. And both of these advances are substantial, unlike any other advances we've had in our industry in the time I've been in this industry. And I think you'll agree after we talk about these today. So let's start with resolution and what the impact of resolution is having, because it's more than just pretty pictures. Obviously, stepping up in resolution is going to bring us pretty pictures, but there's a lot more to it than that. And certainly the biggest thing that people have noticed, and you've heard a lot about both on the professional side and the consumer side, is 4K. And exactly what is 4K and what difference does it make? I mean, from the standpoint of a consumer, obviously they are going to get televisions that have much higher resolution than the televisions they had before. Now, granted, as you know, it's going to be years before the content catches up, right? I mean, there isn't any good 4K content, and the 4K content that is available to stream is massively compressed, so it doesn't look good anyway. So there's some limitations there. But in our segment of the industry, there's a lot of opportunities there that are beyond just the resolution itself, and that's what I'm going to focus on. But to do that, I want to talk about a little bit of history and talk about sort of where we came from and where we're ultimately, or what led us to be where we are today. So a little bit of an evolution of this resolution that we're at right now. So many of you may be using terms interchangeably without realizing, and I know that manufacturers in our industry are sort of using 4K in a lot of different ways. Some of them are a little bit deceptive, and so I want to give you a little bit of an education of exactly what 4K is. And it comes down to ultimately two organizations that have competing interests that are not perfectly aligned. One is called SMPTE and the other one is called DCI. SMPTE's been around for over 60, almost 70 years, and they're the ones that have been setting the standards for consumer television, for example, among other things. In fact, they just published last week the standard for sending video over IP networks. It's the first standard for doing that in our segment of the industry. So they do a lot of that kind of stuff, right? And so their interests have been in protecting the consumer. So for example, when we changed from black and white to color television, they said, look, this system has to be downwardly compatible. We'll help manage this sort of evolution. When we went from SD to HD, they were part of that. DCI, and of course they have an interest in 4K because we're sending 4K to the homes, and they want to make sure that people that have current generation televisions can watch the content as well. So everything needs to be downwardly compatible. But they're also concerned with quality. They want to make sure that quality is as high as possible. DCI is Digital Cinema Initiative. Those are the people who their interest is movie theaters. They want to make sure that movie theaters have a certain quality of experience for the moviegoer. So you're paying a lot of money, you get that experience. The interests of these two organizations are not aligned. One doesn't really care about the other, and one doesn't necessarily relate to the other. So therefore, those two organizations couldn't agree on one 4K standard. So we're actually left with two different 4K standards. And let's talk about sort of where we've come from as our industry and where we are ultimately ending up. So how many of you remember, how many of you have been in the industry long enough to remember how awesome it was to have 640 by 480, right? I mean, so we look at that. Now this box here represents 640 by 480 pixels, by the way. So you're actually looking at 640 by 480. So you remember the days when you take that and blow that up to a screen this large and you're like, that looks awesome. And it did. I mean, it was. When you compare it to what we had before, how many of you remember CGA and EGA and TTL signals and all that kind of stuff before we went to analog? Okay. So that's what happened before VGA, and the PS2, the IBM PS2 computer came out, and that was a big deal. In fact, one of the first distributors of the PS2 in our industry was located right here in Seattle, Washington, back in 1988. So 640 by 480 was a big deal. So what we were doing is taking that density of pixels right there and blowing it up to be on a screen this large. So we were doing image magnification, right? But the problem is, when we did that, although it looked awesome compared to what we had seen before, there was still a lot of dithering and stair-stepping and all that kind of stuff that you'd see. So of course, we stepped up the resolution. This transition took about 15 years to go from 640 by 480 to HD as a standard. So most of the projector monitor manufacturers, display manufacturers were standardized on 640 by 480 manufacturing of chips, and then we went to HD, and that's where we've been for about the last 10 or 12 years, depending on the technology. And you'll notice that at the same time HD came out, this thing called 2K came out. We have in our industry been using those terms interchangeably, even though they don't necessarily mean the same thing. 2K is 2048 by 1080, and HD is 1920 by 1080. What's the difference? 2K is the standard for movie theaters. It's the DCI standard for displaying content in movie theaters. So when you go to a movie theater today, there's here in Seattle, probably 95% chance you're going to see it in 2K. You maybe have only about 5% of your theaters have 4K projectors in them. So most of the content that's being delivered on projection screens in movie theaters is still in the 2K realm. The reason why they wanted a wider aspect ratio is because the film industry believes that the human aspect ratio is wider than basically consumer television believes. And so this might be a good time to explain why we even have those aspect ratios. Because as you know, 16 by 9, right, is almost 2-to-1 aspect ratio. So you might have any idea how we got that, like where that came from? Okay, so if you hold your hands in front of your face, like this, right in front of your eyes, and you start to separate, and you go as far as your peripheral vision goes, and then do the same thing this way, that's 16 by 9. So that's most people's peripheral visions. About fighter pilots, they might have a little bit. People who grew up playing video games, people like that, might have a slightly wider aspect ratio of viewing. So the field of viewing for the human is about 16 by 9, and that's why we have televisions that are that way. That's why movie theaters are that way. The movie theater industry wants to immerse you in the content, so they wanted a wider aspect ratio. So that's why theirs is slightly wider. So then we had these ancillary resolutions that came along thanks to Dell and Apple and companies like that were standard resolutions for building display technology. And then now we've moved into 4K UHD and 4K DCI. So there's two different 4K standards. 4K UHD is pretty much the standard being used in consumer television, in the consumer world, and most of the stuff that we're going to see in our industry as well for commercial display purposes. 4K DCI is the standard resolution for movie theaters. So as movie theaters upgrade from 2K to 4K, the projectors that'll be put in movie theaters so that they match the same aspect ratio so they don't have to replace the screens will be 4K DCI resolution, 4096 by 2160, so slightly wider aspect ratio. So there's two different standards, right? One's 4K UHD. So the 4K UHD actually means 3840 by 2160. So that's what it means when you see it written somewhere. 4K DCI means 4096 by 2160, and that's actually the defining standard. So there's logic behind the terminology, but rather than just using the terminology interchangeably. All right. So if you're paying attention, obviously you know there's two different standards, but we also have some other issues in the world of 4K that matter besides just making higher resolution images, right? So certainly we're going to get awesome looking pictures thanks to 4K, right? One of those factors is color, and we've seen a significant improvement in color because of new lighting technologies. And this is the other giant technological evolution happening at the exact same time that we have this resolution thing happening. So I want you to put on hold for a second. Yes, we have 4 times the resolution, 4 times the number of pixels in 4K than we had in HD. But that's not the big advantage for our market. For the consumer market, it's an easy, low-hanging fruit sale, right? Somebody comes into Best Buy and wants to buy a new TV. Of course, they're going to buy the one with 4 times the number of pixels than the one without when the pricing is only 15, 20, 30%, and even 50% more, right? But in our world, that's not how we're going to sell 4K. And so hold that thought, we'll come back to it. The other technological revolution happening at the exact same time is this thing about color. And this is something that you should really understand because this is pretty substantial. In the projector world, the biggest advancement in color comes because of laser projection. And the way a laser projector works very similar to the way that standard lighting projectors, lamp-based projectors worked over the years, where we're taking the light source and splitting it into red, green, and blue elements, right? There's all sorts of methods of doing that, using filters, using a prism, using a light combiner, whatever we use, and then we're sending that through individual LCDs in the case of Epson projectors, a red LCD, a green LCD, a blue LCD, or an LCD for red light, or LCD for green light, and an LCD for blue light, and then we recombine it with the lens, and then we project it, right? But the difference here is all of a sudden we've taken the lamp that was in the projector, taken it out, and replaced it with a laser light block. That is huge because all of a sudden we have white light that we're starting with, whereas before, with the older projection technologies, before laser or before any solid state lighting technology, the light wasn't white. It was yellowish or reddish or greenish or bluish. So what we were doing inside the projector is we were using filters to color correct for the lighting problems that lamps had. Every time we did that, we affected the uniformity of light on the screen in addition to the colorimetry of the image itself. So we were changing the color in some way. So we had to have some sort of trade-off. We'd have to, every time we built a new projector, we'd have to trade off one color for another. So if we had really good red, that means our green was going to be off. If we had really good green, that means our blue was going to be off. So we're always making trade-offs. For the most part, most projector manufacturers decided that humans love the color blue, so we're going to make blue look really good, and red and green are going to suffer. And that's what projectors have been for the last 15, 20 years. Anyone have any idea why we make pictures look bluish right now? Why we color calibrate all the televisions at home in the 9,000 Kelvin range, or why we make really blue-looking images with projectors? Well, hold that thought and I'll tell you in just a second, because there is logic behind it. So the benefits of laser go well beyond just the fact that we don't have to replace lamps anymore. Yes, that's a huge deal to the consumer, right? We don't have to replace lamps, but there's more than that. So we're not going to have to allocate any money for that. But the image, colorimetry of the image is the big substantial thing here. That's the thing that's going to blow people away. It's because when you compare a standard lamp projector to a laser projector, you're going to see a substantial difference in color. And I'll actually demonstrate this for you right in front of your very eyes in a very small way. So this colored thing that's happening is going to be the biggest thing that's happened in our market in a long time. And I would contend that it's bigger than the resolution change from 2K to 4K or from HD to 4K, and I'll actually show you why. So for those of you who've heard of the CIE color space, how many of you have heard of color? Okay, so this represents all the colors that the human eye can see. And this is sort of a 3D model of it. I'm going to show you a different representation you've probably seen before. But what I want you to see is that this is not just a flat two-dimensional model of color, it's a three-dimensional model of color. So we have all the color in this direction, we have all the color in this direction. Out here is white, back here is black, and everything in between white and black is every color that exists. The human eye sees a lot more color than a camera does. The human eye sees a lot more color than a projector can project or than an iPhone can show you on your screen. How many of you have noticed when you take a photo with your camera, it doesn't look exactly like real life? It gets better and better the better the cameras get, but it doesn't look exactly like real life. And it's because of this. So how many of you have heard the term D65 before, or 6500 Kelvin? Raise your hand. So a few of you have. Okay, so back in the 1930s, SMPTE decided that that was the white point for color, meaning that was what was going to represent white. And most of you might think, well, white is white. What's the difference between white and white? Well, white isn't white. If you look at the white badge that you have and compare it to the white tablecloth in front of you and the white coffee cups, you'll see that those are three different shades of white. White can mean lots of different things, and you don't notice the difference until you have a reference. So when you put all the different shades of white together, then you see that there's a difference. When you take them all away and you're just showing one, then of course everyone points it out and looks at it and says it's white. So this is white, and that's black. Who can tell me how we make white in projection? Throw it out. How do we make white in projection? Right, so we add all the red, the green, and the blue together and we get white. So how do we make black? What's that? No light. Okay, so if we don't project black. Black is the absence of light. So that black box up there is taking away red, green, and blue, right? What color is our screen? So how are we getting black? So we're taking away red, green, and blue on a white screen and calling it black. So that means we're crushing our colors considerably because black is actually not black. Black is actually a shade of white. So we are eliminating the ability to get any of these colors. These colors are thrown out in the world of projection. All right? So what we're going to do is try to maximize the amount of light and maximize the amount of color we can get because we're already at some level of a trade-off. But what's cool about this is this new advancement in, for example, laser technology is going to significantly increase the amount of color we can display because of it. So this is 100% red, 100% green, 100% blue, or white, and that's black. So this point in the middle of red, green, and blue, D65 or 6500 Kelvin, right in the middle there, is white. If you'll notice that white resides exactly in the middle between red, green, and blue. So if you get 100% red, 100% green, 100% blue, you get white. And that's the shade of white. We were told by SMPTE that the industry was told that that was what was deemed as white. Humans, however, don't like this shade of white. humans look at that shade of white and see it as reddish or greenish. So what we did was, starting in the late 1930s, starting in the late 1940s, we started shifting this white point towards blue. And in fact, all the consumer televisions that you buy today are in the range of 8,000 or 9,000 Kelvin instead of 6,500 Kelvin. So they're actually over in this range here. Anyone know why? Why do we do that? Why do we shift it into the blue? For the same reason we've been putting blue dye in laundry detergent since the 1930s. Because humans like the color blue. When we wash something white and we add blue dye to it, which is what laundry detergent does every time you wash it, it comes out looking crisp, clean. If you take something that's white and wash it with something that's red, it comes out pink. You wash it with something that's yellow, it comes out dirty, or green, it comes out dirty-ish. Wash it with blue, it looks nice and crisp and clean. So blue to humans, most humans, except for those that are colorblind, look like crisp, clean white. So we make our white bluish, which has been the same thing that projector manufacturers and monitor manufacturers have been doing for years. We've been color calibrating them towards blue because we haven't had the colorimetry to get the wide gamut of color. There's some great stories about this. Back when Coca-Cola opened up the world of Coca-Cola back some 20 years ago, it was a big deal because it was the world's first live HD theater. So it was, before HD was available for the homes. How many of you gone through the World of Coca-Cola tour? Anybody gone down to Atlanta and gone through that? You go through it and they talk about how awesome Coke is. And at the end of it, they have this movie about how Coke is all around the world. So they were getting ready to open that up, and the president of Coke goes and takes a tour, and he goes in there and they show him the movie, and he says, "We're not opening this up tomorrow. That's not Coke Red." So he was so used to exactly that shade of what they called Coke Red that he could tell that that projector wasn't Coke Red. Why? Well, because we're color calibrating all the projectors to be bluish. So that means all the red and green is thrown off. So Sony sent 2 engineers from Japan to go in there and color calibrate those projectors for Coke Red, which they did. 2 days later, he came in, went through the tour and said, "Perfect." Everything else looked terrible. Coke Red looked perfect, but everything else looked bad. Why? Because what we did was everything was color calibrated for that red, which means that the blue and the green was off, right? So you couldn't have it all because there was a limit in colorimetry. With laser projection, that doesn't exist. And it's pretty substantial. So let me give you an example of how substantial this ultimately is. So that black triangle right there, that black triangle represents the highest, best colorimetry projector you put in up till now that wasn't laser. This is how much color. So this right here, this CIE color curve, remember it's 3-dimensional. We're only showing it to you in 2 dimensions here. So it goes this way too. White here, black back here, all the color here. This is what the human eye can see when you go outside. This is what the very best projector you've ever installed could capture of that. And granted, the customers may not notice because you don't have a reference. It's just the same thing. When you go out and take a picture and you go back and show your friends the picture, they're like, "Wow, that looks amazing." But of course it doesn't look like it did in person, right? So without a reference, this looks awesome. We take the exact same projector and all we do is change the lamp from the current technology we've been using to laser technology and look at the difference in colorimetry. So we're changing nothing else in the projector. We don't change the light block in any way. We don't change the color processing in any way. All we do is change it from a lamp-based projector to a laser projector. We're going to capture anywhere from 40 to 60% more color. So the customers are going to see this and get blown away because you're going to see so much more color. It's going to look so much more real life. So the resolution is one thing, but the colorimetry is substantially better perceptually to the customer. And I'm going to demonstrate this by showing you how this works only by using HDR on and off. So I'm not even going to show you the full colorimetry. I'm only going to demonstrate this to you by just turning HDR off and on the same image side by side. So I'm going to show you an image here. The one on the left, both were taken with an iPhone. The one on the left is HDR off. The one on the right, same picture, is HDR on. No, this was not sent through Photoshop. This is literally two separate photos taken 1 minute apart from each other. Left is HDR off, right is HDR on. And I want you to notice there's a huge difference in colorimetry here that at first you don't really see. So left HDR off, right HDR. When you look at them, you go, well, both of them look awesome. But when you look carefully, you go, look how much stuff is missing. Look in the right picture. Look at the clouds that don't exist on the left. But more importantly, look at the power lines in the right side that don't even exist on the left side. So when you have higher colorimetry, and this is no Photoshop, no modification, all we're done is turning HDR off and on. Higher colorimetry to a human is perceived as higher resolution. So in addition to having 4 times the number of pixels on the screen, we're going to have a huge increase in perceived resolution through higher colorimetry, through meaning better color. So we're going to throw a lot more color on the palette itself. So we're going to gain a much higher color gamut, color potential, which is also going to add to resolution at the same time. So imagine going from a 2K projector to a 4K laser projector at the same time. It's like boom, boom at the exact same time rather than just one improvement. It's going to be huge. So in addition, but there's something even greater than just better quality images that we're going to see. Now I'm going to show you another picture using a higher quality camera. I'm going to show you the same thing using a Canon 5D, which is a 3 CCD imager camera. So this was just with an iPhone. Left HDR off, right HDR on, no Photoshop, no modification of the pictures. When you look at the one on the left, you're going, that's a damn great looking picture. Look at the one on the right, you're like, holy mackerel, how much stuff have we been missing? So the human eye could see all the stuff on the right, but the stuff on the left, the camera couldn't even perceive. And that's only HDR. So we're not even talking about the triangle giant difference in colorimetry. That's just turning HDR off and on. So this is going to be huge. Huge, bigger than anything that has probably happened the entire time you've been in this industry. Bigger than anything. I can't think of any other technological revolution that we've seen. Why? Because everything we see is what we see. We're affected by everything that we see all the time. Sending stuff through IP, through a network, or over HDMI versus VGA, ultimately we don't even see that stuff. We just see the beginning and the end. This is the stuff that we actually see. So yes, AV over IP will be a big deal, but all we're going to be doing there is just making sure what we see here looks like what we see here. And if it does, it does. If it doesn't, it doesn't. We'll just keep working at it until we improve it. In this case, we're just going to see a huge improvement right away, even without a reference. So, and just imagine where we are now. This is first generation. This isn't even second, third, fourth generation. This stuff's going to keep getting brighter and smaller and better over time. This is just first generation stuff. So when I come back here 5 years from now and do a presentation, that triangle will probably get even wider and wider. I mean, we have the potential of actually reproducing exactly one day what the human eye can see. And of course, the cost will come down over time as well. So, I mean, that's just like every technological advancement. So, in the world of projection, this is going to be huge because, sure, we can put flat panel displays like that, but look, this is a great example of everything that's wrong with flat panel displays. Because when those are off, they're still there. With projection, when it's off, it's not there. We don't have to have those rectangles there all the time in the world of projection. We can make things appear and disappear at will. So we're going to see, in addition to obviously signage display technology, which will continue to be available both in flat panel display technology and projection technology, but we're going to see imaging that you can't get with flat panel that is even affordable. Like if you look at the cost per square inch, per square foot, however you measure it, it's substantially less expensive for projection than it is for flat panel display technology in any realm of anything larger than 65 inches. Heads-up displays, lighting. So now we're going to see, what you're going to see is projectors used for ambient lighting. You're going to see projectors used for applications that you never thought of before, because we can do image mapping. We can make it appear wherever we want it to appear. We can change the ambient color temperature of a room with projection technology. And because they're color accurate displays, you're going to see them, projectors, the fastest growing segment of projection, new market for projection, is digital signage. Because what's happening, you're seeing people put, in fact, the hotel they put us in here in Seattle, the Renaissance, is using projection for digital signage to project outside of the hotel itself on the windows of the hotel, because we can put it wherever we want it to appear at any time. So that's interesting in retail applications. Wayfinding, storefront projection, as I mentioned, virtualization, because we can wrap projection around these poles, right? We could use two projectors, and we could, using two projectors, either mounted at the bottom of this pole or the top of this pole, we can wrap the entire pole in imaging. We don't have to use those. I mean, that's obviously, cost-wise, that's an easy thing to do, right? But wow factor-wise, you get a whole different level out of projection when you wrap the entire pole top to bottom with projection. So there's going to be a lot of applications of projection, and thanks to laser and other solid-state lighting technologies, we're going to continue to see growth in that segment of the market. So you're going to have to think outside of, sure, no question that in the boardroom, conference room, training room market, whenever you're putting in a display 70 inches or smaller, you're going to have an effect with flat panel display technology, unless you want to go interactive. When you go interactive with a BrightLink Pro type projector, then obviously the price-wise, it's going to be a lot less expensive than flat panel display technology. So solid-state lighting is going to change everything when it comes to colorimetry. And it's not just going to happen in projection technology, it's going to happen in flat panel display technology as well. You see the flat panel market going from fluorescent-based to LED-based to OLED-based, which is going to have a huge impact on flat. If I were a flat panel manufacturer and I wasn't making an OLED display, I'd be concerned that I was going to disappear. Because when you look at OLED compared to normal LED or LCD technology, it blows it away. It's not even, there's no A-B comparison between the two. It's like A-Z comparison between the two. So OLED's going to have a significant effect on the flat panel display market. We're seeing it appear in places like keyboards, in laptops, external keyboard applications like this, and the Movero glasses, for example. They're somewhere here on the show floor. Epson's brought their Movero smart glasses here to the show, which are interesting. They are using little silicon OLED displays inside of them, and they're augmented reality glasses, right? So what happens is you're actually able to see the real world while wearing the glasses and having content augmented in front of you while wearing them. And you should definitely go to wherever they are. Where are they? Over here. Okay, back over here. And get a demo, because, for example, you can fly a drone legally because you can see the sky but also see what it is seeing through the OLED display. So these are little OLED displays, and this should give you a little clue at where the future of Epson's going to go with display technology as well. They're not just going to be tied into a single type of display technology, as they've expanded already using OLED, silicon-based OLED technology, which is very, very small. These displays are teeny tiny displays. They're less than the size of a fingernail inside of these glasses, and you're able to still see through the glasses themselves. So you should check that out, because this is another application of lighting technology and display technology that is solid state based. And the future of silicon-based OLED technology goes well beyond sort of our market. You're going to see it in phones. Obviously, the new iPhone 10 from Apple uses OLED technology. And you're going to see it in large format display technology as well, replacing LED technology one day. Obviously, and because it can be built in flexible form factors, right? It can be built in different shapes. That's going to have an impact as well. But ultimately, right now, where we are with large imaging is the best way to do it is, in the least expensive way, and thanks to these new laser technologies, is using projection technology. And it has some big benefits over flat panel display technology. Like I said, they're not always there, right? These are off and they're there, so you have no choice, but they're hanging all over the place and they're there all the time. So, and for virtualization, where I want something to appear wherever I want it to appear, there's really no other way for it to be done. And of course, large form factor, where we're doing image mapping on the sides of buildings and walls and environments like basketball stadium or arenas and football stadiums on the floor, on the grounds. I mean, you can't do that with any other technology. So certainly projection technology is going to still continue to flourish in those applications. But the application beyond resolution, beyond color, that is going to be the biggest for our market is digital canvases. And what do I mean by digital canvases? Well, if you think about what you've been doing up until now as an integrator, is you've been installing a projector in the ceiling or on the wall that allows you to project a certain amount of content on the screen. But in reality, the content that is available for the customer or from the presenter is this big, huge canvas of content that can include pretty much anything at any moment in time. Now, I've been presenting to you today using Apple Keynote. Keynote is basically Apple's version of PowerPoint, right? And it is very much a linear presentation tool. Slide 1 to slide 2 to slide 3 to slide 4 to slide 5. So I teach at the University of North Carolina. I teach marketing classes at the University of North Carolina. And often while I'm teaching, a student will ask me a question. I won't say wait till the end, as I get a chance to do to you guys. I can say to you, wait till the end, I'll answer any questions, I'll demonstrate whatever you want. But when a student in the middle asks me a question. So then they say, well, whatever the question is, I'll say, well, let's go show this to you, let's demonstrate this to you. So for me to demonstrate this, because I'm using a linear teaching tool, I have to hit the escape button while I'm in Keynote, just like you would with PowerPoint. And I'd open up a browser and go to YouTube and type in the name of the video, and I'd show a video, and then we'd discuss it in class, and we'd go back and forth between. That's nonlinear learning, which is the way that millennials learn today, is through nonlinear methodology. Why? Because that's how they were brought up. How many of you have kids? Watch your kids. That's how they watch. They even watch TV, a linear device that is only offered linearly, nonlinear. Meaning, even if they are watching a television program with you in the living room on the Enchanted Botch, which is highly unusual and highly unlikely, if they are, they're also second screening with their phone at the same time. So they've created a nonlinear environment out of a linear environment. More likely, they're in their room watching on a nonlinear device using a nonlinear tool, i.e. an app, to pull up the show so they can watch it wherever they want, whenever they want. And then they might be doing homework while listening to music and playing video games and also talking to their friends through FaceTime or whatever. That's how they were brought up. They were brought up in a nonlinear environment. We, for the most part, most of you are in a similar age demographic as me, we're all brought up in a linear environment. So imagine being able to present all your systems in the future in a nonlinear way, so that the presenters that are only comfortable presenting linearly could still use the room, yet you would build all your rooms in the future in a way that could be used nonlinear, so that they could present whatever they want to present, wherever they want to present it, so that you'd see this entire digital canvas all the time. Before I show this to you, I want to mention to you, for those of you who are integrators in here, if you don't tell your customers this exists, I guarantee you they won't buy it from you. Does that make sense? If you don't tell your customers this exists, they definitely won't buy it from you. But if they know this exists, they might buy it from you. So this gives you the ability to create an immersive environment in any room you do, boardroom, conference room, classroom, whatever kind of facility you want. So where I want to do is first show you where we're ultimately going to end up in a truly immersive environment, and then I'm going to show you like the steps to get there. This video was made by Rolls-Royce, and I watched it I don't know, a year ago, and I was like, this is exactly my vision for where I think our industry is going to be in the future. This is what I've been talking about for the last 5 years. So what this video is showing is Rolls-Royce has said, you know what? We can change the entire shipping industry by not making it by making it where people don't have to be on the ships. We will drive the ships from a central location and we will turn them into completely autonomous ships, and we're going to set up a command center so that we can captain all those ships from wherever we want to have them captained. So what we're going to do is we're going to stick an individual in an immersive environment where they're immersed with all the information they need simultaneously. Sort of like the pilot of an airplane, a weather person, and a control tower person all in one place, but one person all doing all three at the exact same time. So flying the plane, watching the weather, and watching the radar all simultaneously with one person. That's what they want to do with ships. That's going to require complete immersion all the time, the ability to see anything all the time, anytime they want to see it. That's not how we present, for example, and that's not how we typically build systems for our customers. But interestingly enough, it's how our audience, especially those that are 36 years old and under, millennials, want content delivered to them. They want to be able to see whatever they want to see whenever they want to see it. That's why they're using the phone in the middle of a meeting while you're having a meeting. And you can see it based on the age. Next time you have a meeting in your own company, watch the age of the people that do this. The people over the age of 35 or 40 years old are generally significantly more attentive visually to the presenter than the people under the age of 35 who are second screening because they want that constant connectivity of immersion. So the way you do that is by building digital canvases. So instead of taking a classroom and putting in a screen that is 16:9 aspect ratio and only limits you to the area of the screen, project on the entire wall. Put up a giant digital canvas. So the screen that you would have normally put in this room would be the size of that current slide rectangle there. So if you were using the Infocom, how many of you are Infocom CTS certified? Okay, so I helped write the video section of that when the first course existed. You remember that section where we talked about the height and width of a screen is based on the location of the least favored viewer. So we have to calculate, you don't want them to be more than 6 times away from the height of the screen, all that kind of stuff. Throw all that out the window. Why? That was all developed based on 1920 by 1080 resolution displays. Everything should be changed based on 4K. So hold that thought for a second, I'll come back to that. So if you're using the Infocom CTS or Avixa CTS guidelines for designing a room, the screen for this room would be the size of that current slide rectangle. So for those presenters who are over the age of 40 that might be frustrated by presenting nonlinear, you could go and you could set the room that when they log into the control system or they turn on the room, that the only thing that lights up is that little rectangle right there, and whatever they plug into the HDMI cable just appears there. But for anyone else who can present nonlinear or who wants access to all the content all the time, light the whole thing up. So imagine you're presenting and the current slide is here and the last slide I just said was here and the one before that is up there, so that you're able to continue to take notes while the presenter is presenting the current slide of the previous slide. And if someone asks a question and I got to show a video, I pull it up over here, but I still have my slides up at the same time. And by the way, I have my Instagram feed, my Twitter feed, and any other pieces of content I want up, depending on what kind of class I'm teaching at any moment in time. This could not have been done in HD. Why? It would have looked like crap. You could have, technologically, you could have done it, but it wouldn't have looked good. Why? Because the most favored viewer, the person sitting in the front row, would see nothing but pixels. It would look like a bunch of little, it'd be like the person sitting underneath the scoreboard in that stadium. The scoreboard looks awesome when you're about 50 feet away or 100 feet away or more. When you get up close, it's just a bunch of little round dots. 4K changed everything. And this is why you have to change the design parameters of the room. The least favored viewer design parameters are still exactly the same. But now we move everything closer to the screen. The reason why the most favored viewer is sitting 1.5 times the width of the screen away from the screen, the reason why that design parameter exists is to make sure that the person sitting in the front center of the front row doesn't see pixels. Now we've put 4 times the density of the pixels on the same screen. Move them on up. So you need to be changing every room you're designing everywhere, even if you don't do this digital canvas concept. And that's why huddle rooms are going to be huge, because now you can sit literally right up to a screen and still not see a pixel. It's not like we couldn't see the content. It's just if I were sitting here in 1080, all I would see is a bunch of pixels. But now in 4K, I see all the content. Yeah, I might have to do like this, but okay, sit them here instead. You can sit people all the way up as close as you want. That encourages immersion. The young people will sit in the front of the room, and the older people will sit in the back of the room. But it gives the customer or the instructor the ability to have a non-linear environment like this and present any way they want. And you're going to sell a whole lot more technology for the same price, because the price of this stuff keeps coming down. So you can do this with projectors. Technically, you could do this with projectors in the hundreds of dollars, not thousands of dollars if you did multi-imaging, right? You use multiple 1080 projectors to build 4K images and seam them together using image mapping, and think about that. So that's one way of doing it. But for this particular room, this would take, to do it the way I think you should do it, use 2 4K projectors. One shooting the left content, one shooting the right content. And of course, if you want, of course, you're not going to get, no matter what, as good as a colorimetry or as an image without a screen as you would with a screen. So I would encourage you to put one giant screen on the front of the entire room. But if you're limited because you can't find a screen company to do that, or you want someone to be able to touch it, then you might just use the wall. So, or if colorimetry isn't the key factor and usability is a key factor, project on the wall. Remember, you can color correct for the color of the wall too. Because in laser, we have way more color in there than we would with normal projection. But this is not just limited to small classrooms and meeting rooms. This could be, you could do this to large lecture halls as well. In this case, I'd be using 3 4K projectors seeing together. And in small meeting rooms. So I still have my interactive displays here, but I'm projecting on this entire wall. In fact, I could even project the door on the door or around the door if I wanted to. So this is the screen. The size of the screen would normally be in that room, but I'm adding all the other content I want. If somebody comes in there that doesn't want to present, project the sides as curtains, or project the sides as a lack of video, which would be black. And I'm sure you've all noticed, if you haven't yet, go around and look at almost all the projectors here are laser projectors. Look at the black. The black is almost black. I mean, it's as black as you've probably ever seen in projection. It's not gray anymore, it's black, right? I mean, so therefore, if I'm projecting black here, or the absence of light, I'm going to get pretty black. And we can't do much better than that because we are, again, projecting on a white screen. So I want you to keep in mind this digital canvas concept as you're building systems in the future, and also keep in mind that you should change the design parameters of your room and start thinking about sort of immersing people in the room rather than keeping them afar based on the technology that we have today.